All right, so this lesson is about Unit 1, Lesson 4, and the learning target is I can identify equations that have one solution, no solution, or an infinite number of solutions. So first we're going to start with the do now. So the do now is just going to be us practicing how to solve multi-step equations. So we have 3 times x minus 2 plus 4x equals 1/2 parentheses 6x minus 4. So we know based on orders of operations we need to get rid of our parentheses s first. So we're going to distribute. The 3 times x is 3x, and 3 times a negative 2 is a negative 6. Bring down the plus 4x equals, now we want to get rid of this 1/2 as well. So we're going to distribute it. So the 1/2 times 6x, remember anything times a half is just halving a number. So a half times 6 is going to be 3x. And then a half times a negative 4 is a negative 2. Now on the left side, we have 3 terms. We know that if we have 3 terms, 2 things need to be combined. In this case, we have a positive 3x and a positive 4x that need to be combined. So when we add 3 plus 4, we have 7x. Bring down the minus 6 equals 3x minus 2. Now we have variables on both sides. We want to bring the smaller to the larger using inverse operations. Remember, when you move something to the opposite side of the equal sign, you use the opposite sign. So we move the 3x over by subtracting 3x. Subtract 3x. Remember, you subtract it from 7x because they are like terms. You wouldn't subtract it from a 6 because a 6 is a number and a 3x is a variable. 7x minus 3x is just 4x. Bring down the minus 6 equals negative 2. Now we need to get the variable alone, so we're going to move the negative 6 over by adding 6 to both sides. Now we are going to bring down, I'm going to rewrite it up here, 4x equals a negative 2 plus 6, put into your calculator is 4. Divide by 4 on both sides, and this answer is x equals 1, which is answer choice B. Part B. We are going to solve for this as well. So on the left side, we have 3 terms. So we're going to circle the negative 8 and a negative 1 to combine. So a negative 8 and a negative 1, it gets more negative. So is a negative 9 equals. Now we have to distribute. 5 times 2 is 10x. 5 times a negative 3 is a negative 15. Now we have to move the 4x over by subtracting 4x on both sides. We want to get the variables on one side and the numbers on the other. Now we bring down negative 9 equals 10 minus 4 is 6x. Bring down the negative 15. We are going to add 15 to both sides. Negative 9 plus 15 is 6 equals 6x. Divide by 6 on both sides. And we are left with, again, x equals 1. Okay, any questions on those, please send us an email. Otherwise, we're moving on to the next page. Here, we have a question. So this is like the explore part. And if you guys were here, you would turn and talk to each other. But we are just wondering, how many values of x make the following equation true? So from the look of this and from what we've always done, we've always solved an equation and have gotten x equals some number, right? So we've always had like x equals a number. And we know that that number is the only answer to that equation, right? So in reality, we've only really seen only one answer work for every equation because we get that one number. And the way we could be sure of what that one number is for this equation is to solve it. So we have to move over and get the x's together. So we're going to move the 3x because it's smaller. So we subtract 3x on both sides. And we're left with 2x plus 2 equals 8. Now we have to subtract the 2's on both sides. And we're left with 2x equals 6. Divide by 2. And divide by 2. And we have x equals 3. So in this case, we were correct. This equation only has one solution. It is x equals 3. One and only solution. Okay? Because now we're going to see times that now we have more than one solution, all right? And this is new to you all since you've only ever seen one solution. So for this slide, they basically just want us to figure out if x equals 3 will satisfy this equation. So when they are asking us to figure this out, they're telling us show that work by using substitution. So that means you are replacing x with 3 wherever it is in the equation. So wherever is a 3, I'm going to wherever there is an x, I am replacing with a 3. So everything else stays the same. I bring the 3 down. The x is a 3 now that they want me to substitute in. And I have 2 times, again, another 3 I need to replace the x with, and 8. Now, you would just type this into your calculator. You could type in 3 times 3 plus 5. Yes, we get 14 equals. Then you type in 2 times 3 plus 8. And yes, we get 14 again as well. So, does x equals 3 satisfy the following equation? Yes, it does, because we see that when we substitute it into the left side and into the right side, we get 14 equals 14. It's the same number, so it works. Okay. Number 2, does x equal 3 satisfy now this other equation? 4x plus 1 equals negative 2x minus 7. So let's see. Again, we have to use substitution. So wherever there is an x, you're replacing with 3. So 4 times 3 plus 1 equals negative 2 times 3 minus 7. So 4 times 3 plus 1, you could type straight into your calculator. It's 13. And then negative 2 times 3 minus 7, type it straight into your calculator again. We get a negative 13. So like we've spoken about opposites, 13 and negative 13. They're not the same. They are not equal to each other. So therefore, when we substitute 3 into the left side of the equation, we got positive 13. And when we substitute it into the right side, we got negative 13. So does x equals 3 satisfy this equation? No, it does not. Because we are getting 13 equals negative 13, so therefore that's not a solution to it, okay? In order for it to be a solution, you have to have it, when you substitute in, it needs to be equal on both sides, like we saw here with 14 equals 14. Down here, if you get 2 different numbers, then you know that can't be a solution, okay? And this bottom one, basically, this was from a Regent. We just want to have you practice again. So we're going to just start by doing our distributive property, and we have 3 times 2 is 2x is 6x. And 3 times 2 is 6 equals. Now on this side, we have 4 terms. So I see an 8x, I'm going to put a box around, and a negative 2x. When I combine an 8 and a negative 2, it is 6x. Now I also have a negative 4, I'm going to put a circle around, and a 10 to show their like terms. Negative 4 plus 10 is plus 6. Very good. So now I'm going to just continue solving. Negative 6. Minus 6x. We don't like, it wouldn't be wrong, but we don't like you to move the numbers first. We prefer you to move the x's. And then we minus 6x. So on both sides they cancel out. And we have 6 equals 6. 6 equals 6, yeah. That's correct. But what does that mean? So this is new right here. I put a star next to it. This is the first time you guys are seeing an equation that when you solve it, right here at this step, your x's are gone, right? And so when they disappear, you're left with just numbers on both sides. And in this case, you have the same number on both sides. So this means that this entire original equation has infinitely, I'm going to spell it out, infinitely many solutions. So that means no matter what value of x I substitute in here, here, and here, I will always get a number equal to the same number. Any number I substitute in will always satisfy this equation. And to have infinitely many solutions, when you finish solving, your x's would disappear and you would have the same number on both sides, okay? So this is just an introduction to this, and within the next slides, we'll go over more in depth of other examples. Okay, so Jason says that a linear equation always just has one solution. Amy says that some linear equations have more than one solution. We know that we've just seen there's a possibility to have infinitely many solutions. So we are going to solve this equation and see if it can have more than one solution. So based on what we said before, okay, just to backtrack, when you solve that other equation, the variable disappeared and you were left with a number equals that same number. So let's see if that happens in this case, because then if it doesn't, then we have to see what the real solution is. So let's start by solving. We have a 2x and an x. Remember, in front of that x is always a 1. So it's really 3x plus 1 equals, now we use the distributive property, 3x and minus 6 plus 7. Now I have nothing to do on the left side, but on the right side I'm going to combine a negative 6 and a 7, and I'm left with 3x plus 1 equals 3x plus 1. I'm going to move the 3x's over to combine them, and I'm left with 1 equals 1, and again, the variables canceled out. I'm left with the same number on both sides, so therefore this has infinitely many solutions. So you know that any value of x that substitutes into this equation will always work for it, okay? So therefore, the bottom part B, is there another value of x that satisfies the equation? So they just want you to pick 3 values. So I'm just going to do one for the purpose of this, but when you guys submit your work, please show us 3 different numbers you've tried. It could be positives, it could be negatives. So I'm just going to choose x equals negative 2. So if I type into and substitute in 2 times negative 2 plus 1, and then I replace the x with a negative 2, equals 3 times negative 2 minus 2 plus 7. So now you have to solve it. This would be a negative 4, and then plus 1 minus 2. And over here, 3 times negative 2 minus 2, we're going to leave the 3, combine what's in the parentheses, which is negative 4 plus 7. And on the left side, we have negative 4 plus 1 is negative 3, minus 2 is negative 5. And over here, we're going to have 3 times a negative 4 is a negative 12. Add 7 to it is negative 5. And as we can see, x is negative 2 is a solution. Now you guys can try 2 other numbers and see if they work out as well. Let's clear this page. Edit. So now we have this page, all right? We are going to go through each one and we're going to go into detail about what each solution means. So this case, we haven't really seen this yet, but they want to know which equation has no solution. So we're going to go through all these and figure this out together. So let's start with A. We know in order to solve this, we need to get the x's together. So subtract x, and we're left with 2 minus 1x is x equals 1. And we know whenever we have an equation that we solve for and we have x equals some number as an answer, this will mean it only has one solution. And that one solution is the only number that you could substitute in to that equation and get the same number on both sides. It's the only answer that will work for it. So in this case, if you have x equals number is an answer, you know that equation has one solution. Okay? And I just want you to also start to recognize, here's some key things. When you are looking at the original equation, if you have different x values, so here this x value is a 2, here this x value is a 1. If you have different x values on each side of the equal sign, you'll know you'll have one solution. So if it's just asking you to identify what solution this has, and you don't even need to solve it, you can say Oh wow, let me just look at their equation. They have different x values. I know this will have one solution. So I would write this down. One solution will always have different x values. Okay, number 2. I see 3x plus 4 equals 3x plus 1. I don't really know from looking at the equation, so I'm going to need to solve something. I'm going to subtract 3x. We know we always need to get the x's together. And here, all right, my x cancels out. I'm left with 4 equals 1. Now, I don't know about you guys, but 4 never equals 1. All right, on a number line, you have 1, 2, 3, then 4. So, therefore, 1 can never equal 4. So, this means that there is no solution. So, if you solve an equation and you get two different numbers on opposite sides, you know that they'll never be equal to each other. So, that is no solution. And like we said before, let's see how we can identify it looking at the original equation. If you see here, their x values on each side of the equal sign are the same, but the number being added or subtracted is different. So if they want you to just identify it from looking at an equation without doing any work, you should say to yourself, okay, I see they have the same 3x, but this is adding 4 and this is adding 1. So if you logically think about it, if I substitute in a number like 1 in for x, but then add 4 to that, and then on the other side do 3 times that same number 1, but only add 1 to it, can they ever be equal? No, because 3 times 1 will always be 3. But if I add 4 to that, I'm going to get 7. And on this side, 3 times 1 again is always 3. But I'm adding 1 and only getting 4. No, that will never be equal because you can't substitute a number and then add or subtract something different and think you would get the same answer. So down here, our little notes, they have the same x coefficients and different numbers being added and subtracted. Okay? And last but not least, we have this equation and we have parentheses, so we start by distributing. 4 times 3x is 12x. 4 times a negative 2 is a negative 8 equals 12x minus 8. Okay, let's solve it. Get the x's together, minus 12x, minus 12x. Here we have negative 8 equals negative 8. And like we saw before, if we have the same number on both sides and the x disappears, we know this is called infinitely many solutions. And I want you guys to be able to recognize it. So from this equation given, you would have to do the distributive property, okay? So when you finally have two terms on each side or two terms or less on both sides, this is the point where you can look at the equation to determine how many solutions it has. So if we look here, you see on the left side, it says 12x minus 8. And then on the right side is 12x minus 8. So therefore, if you see the same expression on both sides, you know it's going to be equal because 12x minus 8 is always going to equal 12x minus 8. So our note down here is the same expression on both sides. Okay, and we are done. So same expression on both sides. This question is asking us, so if you guys look here, if you ever see the SE 1-22-17, that means state exam, January 22nd, 2017. So this is asking for what value for the constant P will result in no solution for the equation. So we know that in order to have no solution, the x values are the same but the numbers added are different. So let's look at this equation given. We're trying to figure out what P is. So we know that the X value has to be the same, right? So we are trying to say, okay, when we distribute and multiply whatever number is times 2, we need it to be 6. So what times 2 will give us 6? 3 is our answer. Okay? And if we substitute it in, we could see 3 times 2x plus 5 equals 6x plus 7.5. We distribute 3 times 2x is there is our 6x, and 3 times 5 is our 15. And we know that this will be no solution because they have the same x values, but different numbers being added. And that is our answer. Okay, so here we have Mickey, Minnie, and Donald. So they're each given an equation, and you need to solve for what the solution is to each of those. So on the next slide, we left us some room to do this work. So we're going to complete this slide here. So let's start with Mickey. But from looking at all of these, there really is nothing you can say about them until you do some work and combine like terms. So we can't just start by saying, okay, we know the solution to this. So let's start by getting rid of these parentheses. 2 times x is 2x. 2 times 10 is plus 20 minus 17. Now we bring down the 5 plus 2x minus 2. On the left side, we have to combine the positive 20 and the negative 17. So we bring down 2x plus 3 equals, and now on the right side, we have a 5 and a negative 2. So now we're going to bring down the 2x, and a 5 minus 2 is a plus 3. So looking at this, we have 2x plus 3 equals 2x plus 3. They just want you to identify the solution. So therefore, if you can see it from this step, you can stop and say infinitely many solutions. But if you can't, that's fine. I would even do it myself. Take it one step further. Let's say, okay, I'm going to combine the x's because I can't see the answer. So subtract 2x on both sides, and I'm left with 3 equals 3. And right here, I know when I just solved and the x's disappeared, and I still have the same number on both sides, that means it's infinitely many solutions. Okay, now we're on to Minnie. On the left side, we have to combine the 5x and the negative 3x, which gives us 2x, and bring down the plus 3 equals. On the right side, we have to distribute 2 times x is 2x, 2 times 3 is plus 6 minus 5. Now, I have nothing else I need to do on the left side, so I'm just going to bring down the 2x plus 3. But I can't stop and look at an equation yet until I have 2 terms on both sides. So I have 3 terms on the other side. So I need to combine something, which is the 6 and then negative 5. So when I combine those, I bring down my 2x and I'm left with 2x plus 1. So like before, if you can stop here and recognize that this is going to be no solution, you may stop solving. Because you could see there is the same x value, but different numbers being added or subtracted. So that would be no solution. If you can't see it, go and perform the next step. So you would, I'm going to get rid of these so they don't look like division signs. You would subtract 2x, subtract 2x on both sides, and you're left with 3 equals 1. 3 will never equal 1, so there is no solutions to this. Okay? And last but not least, we have Donald. So I'm going to extend the page. Okay. Donald, we need to start with distributive property. So 2 times x, 2x. 2 times a negative 3 is a negative 6 plus 9 equals 5 plus x minus 1. We can't stop here because we need to get all like terms together. We need at least 2 terms on both sides. We can't have 3. So on the left side, we're going to combine a negative 6 and a positive 9. And we're left with 2x plus 3 equals, and then we have 5 and a negative 1. So we're left with x plus 4. Now, if you wanted to stop here, you could say, I know this will have one solution. Because if they're not asking you for the solution, you don't need to solve for it. And you know it's one solution because this x is a 2, this x is a 1. And we know that if you just have different x values, there will only be one solution. So therefore, you could stop. If not, go ahead and solve it. We're going to move the smaller x to the larger by subtracting x on both sides. And we're left with x plus 3 equals 4. To get the x alone, subtract 3 on both sides. And you're left with x equals 1. And that is your one and only solution to this equation. Okay, so right now, this is like your little summary page. It's basically how you would recognize that an equation has one solution, how an equation will have no solution, and looking at an equation, how it will have infinitely many solutions. So right now, I would just stop, pause this, see if you can come up with how you could recognize it yourself, and then come back and see if what you wrote is what I wrote down as well, okay? So at this point, I would pause it and then come back. Okay, so I have filled it in, and let's just see. I can tell that an equation has one solution when you have different x coefficients. So if you wrote that or something to the point of your x's have different numbers, you are correct. And in my example is 3x plus 4 is negative 2x plus 1. As long as you have different x values, that's all that matters for one solution. 2. You can tell that an equation has no solution when the same x coefficients, but they have different numbers being added or subtracted. So here I have the same x, 3x and 3x. Oops. And they have different numbers being added or subtracted. So on one side I added plus 1, the other side I added plus 4. That's how you know that they will have no solution. And 3, I can tell an equation has infinitely many solutions when there is the same expression on both sides. So you could have made up anything. I just created 4x plus 2 equals 4x plus 2. Or another way you might see it is negative 3x equals negative 3x. As long as it's the same thing on both sides, you know it will have infinitely many solutions. Okay, now we're on to some other practice problems. So go ahead and try these. I would stop this and then I would come back. Okay, so go ahead and click pause and then check these two. Okay, so we're back and we're going to start by solving this. So we know if we just want to look at the equation, here we have a 6x and here we have a negative 6x. They are different x values. So we know in order that if an equation has different x values, it's going to have one solution. So therefore, C, we could cross out because we know that there is no solution is not correct. And there are infinitely many solutions. Choice D, we could cross it as well because we know there is one solution. So now we're going to see if it's negative 10 over 3 or 0. So we start by adding 6x to both sides because you bring the smaller to the larger, and you're left with 12x plus 20 equals negative 20. Now you minus 20 on both sides. I'm going to bring this down here. You're left with 12x equals negative 40. You divide by 12 on both sides. And when you guys type that into your calculator, it will simplify it for you and give you negative 10 over 3, which is answer choice A. The next question, we have to start by distributing on both sides. So negative 8 times 2x is negative 16x. Negative 8 times 3 is negative 24 equals 1/2 times 10x, so a half of 10 is 5x. And then a half times negative 6, so what's a half of negative 6? Negative 3. I know this will have one solution because I have a negative 16x and a 5x. They are different, so it's automatically going to have one solution. So I'm going to bring the smaller to the larger. The smaller x is negative 16. Okay, that's on the negative side. That is definitely smaller than a positive 5. So I'm going to add 16x to both sides. And I have negative 24 equals 21x minus 3. I'm going to add 3 on both sides, and I'm left with negative 21 equals 21x. Divide by 21 on both sides, and I'm left with x equals negative 1. And that is my one and only solution to this equation. Okay, so Kermit looks at the equation negative 6x minus 30 equals 6x minus 30 and says there is no solution. Is he correct? And justify your answer using words. Well, what do we think? Take a minute. We know no solution. Say to yourself, all right, if I'm looking at an equation, what does it mean to be no solution? That means that the x values would have to be the same. And in this case, are the x values the same? No. So therefore, Kermit is not correct. Kermit is not correct because this equation actually has what? So if it's not one solution, in this case, this equation, it's not no solution. This equation has one solution. We know the minute we see two different x values, there is a solution. So let's see what that solution is. Negative 6x minus 30 equals 6x minus 30. And this is your explanation as well. You're going to add 6x on both sides. And you're left with negative 30 equals 12x minus 30. You add 30 to both sides. Okay, here you're left with 0 equals 12x. Please do not stop solving there. 0 is a number, and you still have a variable. This does not mean there is no solution. The only way there is no solution is if the x disappears and you have two different numbers on both sides. But right now, as it is, you are leaving it. You have to finish solving. So to get x alone, you divide by 12. Divide by 12. X equals 0. That's the answer. 0 divided by 12 is 0. So Kermit is not correct because this equation has one solution, which is 0. Okay? We're going to take a look at the fast finisher. So this was from 2015. I want you to determine the number of solutions that exist. So we got to get rid of these parentheses. We have 8 times j is 8j. 8 times negative 4 is negative 32 equals 2 times 4j is 8j. 2 times negative 16 is negative 32. Same expression on both sides. Therefore, this has infinitely many solutions. Okay, we know 8j minus 32 will always equal 8j minus 32. Okay, so take a minute by yourselves. We're filling in the blanks. So I'm gonna pause this and then you come back and check your answer. But you're filling in the blanks so that the equation will have the type of solution shown. So for A, you're gonna try and fill in the blank in order to make this equation have no solution. B, you want to fill in that blank in order to have infinitely many solutions. And C, you want to fill in the blank to have one solution, to make the equation only have one solution. So go ahead, take a minute, and then come back and see what you've come up with. Okay, so we're going to take a quick look at your work. So to make this no solution, we know that the x values have to be the same, but the numbers have to be different. So in this case, I just picked 4, but you could have picked any real number but 5. Any number. So you could have picked any positive number, any negative number, except for 5. Okay, so if you did, awesome job. B, infinitely many solutions. We know we need the same expression on both sides. So if this side says 1/3 x plus 5, this side has to say 1/3 x plus 5. So therefore, 5 is the only answer to that question. 5 and only 5 will work. to make that have infinitely many solutions. And C is one solution. So we know that in order to have one solution, you need to have different x values. That's all that matters. It doesn't matter about these numbers being added. Okay, so in order to have this one solution, you know that it needs to be any real number but 2. Okay, so you could have picked any negative and any positive, just can't be 2. All right, here we have 3 practice problems, so go ahead, take a minute and then come back.